Okay, so this was a problem. Acetic acid is esterified in the liquid phase with ethanol at 373.15 Kelvin and atmospheric pressure to produce ethyl acetate and water according to this reaction. If initially there is 1 mole each of acetic acid and ethanol, estimate the mole fraction of ethyl acetate in the reaction mixture at equilibrium. As I said last time, generally exam में ऐसे ही आता है. They only put this part, they forget to give all the data. Well, that is how this problem in Smith is. In Smith, you have to refer the data from tables and from appendix and get the inputs for calculating. So data for heat of formation and free energy of formation, like acetic acid, ethanol, and water are given in table C-4. So from that table, we have to take that value. And for liquid ethyl acetate, the corresponding values are heat of formation at 298 is minus 480,000 joules, and free energy of formation at 298 is minus 332,200 joules. ये डेटा दिया है. It's not part of the problem. It is given below the problem in the solution. इसीलिए कभी एग्जाम में ये आता नहीं है. And every time it happens that students are stumped. क्या करने का अगर ये. We'll see what to do, how you should approach such problems. Okay. So this is table C-4, C.4, and we have seen acetic acid का values, heat of formation ये है, and free energy of formation ये है. Note down, heat of formation of acetic acid is minus 484,500, and free energy of formation of acetic acid is minus 389,900. And for ethanol, again we will take liquid phase. So ethanol liquid phase में लेने का reaction liquid phase में हो रहा है. So heat of formation is minus 277,690, and free energy of formation is minus 174,780. So you have all these things, and then we need for water also. Water के लिए again you take for liquid phase minus 285,830 for heat of formation and minus 137,129 for free energy of formation. So you can find out heat of reaction and free energy of reaction. Right. So what is at 298 कितना हो जाएगा? What is the formula? What is the formula for finding heat of reaction at 298?
Product minus reactant.
Yeah, summation of nu I heat of formation of product plus nu I लिया तो plus लेना पड़ेगा because nu I has positive negative values. ठीक है. So we can take this as product के लिए acid ethyl acetate का कितना था values बता सकता कोई? What is the heat of formation of ethyl acetate? नोट किया किसी ने? नहीं किया किसी ने?
Sir, minus 4840. 48 4 times 0.
और वाटर का?
minus 285830.
और रिएक्टेंट का दिस फॉर द प्रोडक्ट रिएक्टेंट के लिए
minus 484500.
into -1 हो जाएगा ना,
Yes,
right?
sir.
It's new है, right? Plus
Minus 277,690. 690.
690. Okay. So इसको कितना हो जाएगा heat of reaction?
Minus 3640.
So that is heat of reaction, where we can find out free energy of reaction. Okay, so what is the delta G of our product?
So minus 332200.
और दूसरा
Minus 237129.
129.
Yes.
Okay, this for product. Reactant का
Minus 389900. Plus minus 174780.
minus
174780.
into -1. And this is equal to how much?
Minus 4649.
ठीक है. So once we know this, we can find out what? इसमें से क्या मिलेगा हमारे को?
K मिलेगा.
K मिलेगा. What is the equation?
Delta G equal to minus RTL in K.
So we can put this. R का वैल्यू क्या रहेगा?
8.314.
Into 298 ln of K. So ये कितना हो जाएगा?
6.5299.
5299.
Yes, sir.
Okay. ठीक है. किसी को डाउट है अभी तक? कुछ क्वेश्चन है किसी को? Once you get this, then we need to find क्या निकालना है अभी हमारे को? Rate of reaction is at
K at
we need that K at 373, right? So this is at 298 Kelvin. So we need K at 373 Kelvin, right? इसके लिए क्या करेंगे?
one of equation.
Top equation, right? What is that? Ln K2 by K1 is equal to
Minus delta H R upon R into 1 upon T2 minus 1 upon T.
1 upon
T2.
ठीक है. And use this equation. Find out K at 373. We have ln of K2 upon delta HR कितना था? 3640 upon 8.314 1 upon 373.15 minus ठीक है.
Yes, sir.
So what is the value of K2?
4.857.
4.85.
7.
Is this correct, Siddhi and Dikshita?
Yes, sir.
Okay. So once we get the value of K, then we can proceed as normal. So when you get the question in the exam, right, and they ask you to calculate composition, more fraction of ethyl acetate in the reaction mixture at equilibrium, right? तो ऊपर में कभी भी दिया रहता है assume suitable data, right? Instructions में ऊपर में पेपर में कभी भी, right? So what you should do is you should remember this value, ये प्रॉब्लम के लिए 4.85 something, and assume this value and proceed. And mention it. Data is not given for heat of formation and free energy of formation, or K value is not given, and that is why you are assuming this value of K and proceed further. समझ में आया अप्रोच क्या लेने का?
Yes.
क्योंकि बहुत बार ऐसा देखा मैंने, जितने पेपर देखे हैं, it has come 4 times in the past, 15, 16, 17, 18, 4 years in a row, and no data was given. Generally, when I am there in the examination hall, I provide the data, but if there's nobody to provide you data, assume data and proceed further. ठीक है, तो अभी क्या करेंगे? How will you proceed further now? What is the next step? K क्या रहेगा? How is K defined for liquid phase reaction?
Ky into P raised to.
Ky into P raised to power of nu. बराबर है क्या? Let's see. Last time क्या देखा था हमने? Okay, so this is what it was actually. ये हमने derive किया था last time. Right? K is equal to Kx is equal to pi xi raised to power of nu I. बराबर है? This is what you have to use. We are talking about liquid phase reaction, so this is the equation we need to use, not the other one. Is it understood? Generally, concentration जो reaction रहेगा, it's not going to be very low. So ये दूसरा नीचे वाला था equation. We are not going to use this equation, or rather, ये नहीं use करेंगे हम. A equal to mi नहीं लेंगे हम. We generally use this equation only, equation 8. Okay, so let's proceed accordingly. So it's going to be, so there is no effect of pressure on liquid phase reactions. Okay, so this will be equal to what? X of ethyl acetate into X of water divided by X of ethanol and X of acetic acid. ठीक है, ACH, sorry, not HOH. Acetic acid is ACH, ethanol is ETOH, ethyl acetate ये डाला है मैंने, और water, right? And this we know is equal to 4.857. So what you need to do is we need to find X in terms of epsilon now. So X of ethyl acetate क्या हो जाएगा in terms of epsilon? What is the formula? ठीक है, ये is this formula correct? X or Y doesn't matter, mole fraction ही है वो,
Yes, sir.
right? So if you have this equation, it will be, sorry, this is not ethyl acetate, this is any X of I. So ethyl acetate will be NiH0 कितना है ethyl acetate के लिए? Initial moles of ethyl acetate कितना है? What is the initial moles of ethyl acetate?
0.
And nu I क्या है ethyl acetate के लिए?
1.
Plus
1
1.
to epsilon upon N0 कितना रहेगा? N0 initial
2.
moles
2.
2. 1 mole of ethanol and 1 mole of ethyl acetic acid. Plus nu is how much? 1 plus 1 minus 1 minus 1, right? So nu is equal to 0. So we'll get 0 here. So that is ठीक है. Any questions so far? Similarly, X of water will be same, epsilon upon 2. Then X of ethanol will be 1 minus plus 1 into minus 1 into epsilon upon 2. So 1 minus epsilon upon 2. And X of acetic acid will be again same, 1 minus epsilon upon 2. ठीक है, किसी को डाउट है इसमें? कुछ क्वेश्चन है? देवेंद्र, समझ रहा है?
Yes, sir. Yes.
Okay, so you can substitute in that equation, right? ये equation में डाल के you can find out what is the value of epsilon. Right? So what you'll get is epsilon square is equal to 4.857 1 minus 2 epsilon plus So if you bring it here, what you'll get is so what is the value of epsilon? Two values you'll get, right? क्या values are epsilon का?
1.8307
And
0.68779.
okay, so two values you get for this thing. So we can try both ways, right? क्या आएगा करके. So what we'll do is we'll find out conversion x of ethanol लिया हमने. क्या चाहिए इनको? मोल फ्रैक्शन चाहिए ना? Z चाहिए, सॉरी अपन Z करेंगे ना अपन. Z ऑफ कुछ भी लिया तो एक ही बात है, because they are stoichiometric. So nu I absolute value into epsilon upon ni 0. So 1 into 1.8307 upon 1. So this will be right. So this conversion is not possible. So we'll try with the other one. See, if you show it this way, the examiner will be impressed कि I actually evaluate both the values. Book में कभी ऐसा नहीं देते हैं. They always give one value, select this value and go. No reason given. So if I take the other value, what you get is and this is what we'll take. Okay. So what we need to find ultimately is mole fraction of ethyl acetate, right? So what we need is essentially x of ethyl acetate, which is nothing but epsilon upon 2. Right, so it is 34.39%. ओके, ठीक है. किसी कोई डाउट है, क्वेश्चन है? समझ में आया लोगों को? एनी डाउट्स, क्वेश्चंस? ठीक है, if there are no questions, let us proceed to the next topic. Your unsolved problem है नारायण का, which is exactly similar. So I'll give you that as an assignment. Will not solve that problem. Exactly same similar problem है, only data is little different, slightly different data. So next topic is so can you see this? Hello.
Yes, sir.
Yes.
So next topic is simultaneous reactions. अभी तक हमने सिंगल रिएक्शंस देखा, वी हैव सीन ओनली सिंगल रिएक्शन, क्या हुआ, एक रिएक्शन होता है तो क्या होता है, कैसे करने का. So now we'll see if there are more than one reaction, then how to handle it. Okay. So if you take a reaction for the formation of methanol from CO and hydrogen, this is the reaction which is given here. But actually there are two steps in the series. First is CO plus hydrogen gives HCHO, which is an intermediate, which reacts with again hydrogen to give methanol. Okay. So intermediate products can be ignored on the assumption that they are very unstable. Generally, they are very unstable. Their life or residence time or rather existence time is very small, and their concentration at equilibrium is negligible. ये आपने chemistry में पढ़ा होगा, right? Have you seen that mechanism of formation of compounds and which intermediate is there formed, but it is very unstable? You'll see that in CRE. But let us assume that concentration is very negligible, because जैसे ही form होता है intermediate, it proceeds to the second reaction and immediately it is consumed. So in this case, HCHO or formaldehyde is very unstable, but sometimes it is stable, sometimes it's not stable. So we'll see. So free energy change of reaction is generally equal to sum of free energy changes of individual steps. Like Hess's law. Hess's law याद है आप लोगों को? अभी किया था हमने थोड़े दिन पहले. What is Hess's law? नहीं याद किसी को?
सर वो रिएक्शन एक स्टेप में हो या बहुत स्टेप में हो तो उसका डेल्टा एच कांस्टेंट
Constant नहीं रहता है. Whether reaction takes place in
हाँ,
one step or
समझ
multiple steps doesn't really matter, as long as the reactants and products are same, whether it is in single reaction or it is in two reactions or three steps or four steps, doesn't really matter. The heat of reaction is going to remain the same. This is what we had used to derive heat of reaction at any temperature, right? From heat of reaction at 298. So if you know heat of reaction at 298, उसके बेसिस पे हम heat of reaction at any temperature निकाल सकते हैं. And that's what we had used. Similarly, we can use the same thing for free energy change. Instead of heat of reaction, we're talking about free energy change of reaction. Is equal to sum of free energy changes of individual steps, similar to Hess's law. Right? So delta G0 for the reaction is essentially equal to delta G1 for step 1 and delta G2 for step 2. Right? So free energy change of reaction step 1 and free energy change of reaction step 2, and delta G0 is overall reaction के लिए. And we know that delta G0 is equal to minus RT ln K. This we have derived, right? This is for reaction. Right? And so we can write, substitute in this one, you get minus RT ln K is equal to minus RT ln K1 for delta G10 and minus RT ln K2 for delta G20. Right? So you can combine these two, and what you get is minus RT ln K1 into K2. दोनों combine कर दिया तो. So what it gives is K is equal to K1 into K2. Right? So overall equilibrium constant is nothing but a product of equilibrium constant for each step, K1 into K2. Any questions on equation 2? Okay, so K1, K2 are equilibrium constants of individual steps, and K is for the overall reaction. Right? So if you look at examples, K is equal to K1 into K2, and suppose overall reaction is 10 raised to minus 4, and suppose we have values for K1 and K2. One is 10 raised to power minus 10, and another is 10 raised to power 6. Right? So when you say 10 raised to power 10 minus 10, this is very, very small, right? Because this is product upon reactant. यानी बहुत कम reaction हो रहा है इसका. K1 is very small, and hence concentration of intermediate is very negligible. Because K is nothing but product upon reactant, right? Right. So if K is small, that means Y of product is very small. Hence the concentration of intermediate product is negligible. Okay. Therefore, correct result obtained by considering only overall reaction. So we can take only overall reaction. ये लेके कर सकते हैं हम. Right? And that's what you are saying. कि intermediate is normally very low concentration. because जैसे ही फॉर्म होता है कंज्यूम हो जाता है, सेकंड स्टेप हो जाता है. ओके, सेकंड केस लिया है, k is equal to 10 raised to minus 4. Suppose both are equal, right? Step 1 and step 2 के लिए k1 k2 same है. Suppose 10 raised to minus 2, 10 raised to minus 2. Right? In this case, what will happen? Intermediate is considerable amount because now it is equal. फर्स्ट स्टेप और सेकंड स्टेप का केस इक्वल है. दैट मीन्स जो इंटरमीडिएट है उसका कॉन्सेंट्रेशन सिग्निफिकेंट रहेगा. राइट? एंड हेंस वी कैन नॉट इग्नोर इट. जब के का वैल्यू k1 का वैल्यू ज़्यादा रहेगा और कंपेरेबल टू k2 रहेगा तो देन वी कैन नॉट इग्नोर दैट इंटरमीडिएट. समझ में आ रहा है? एनी क्वेश्चंस सो फार? ठीक है. And the last example is k is equal to 10 raised to power minus 4, and then we are taking similar things. But now the k value is higher, k1 value is higher, 10 raised to power of 6, and k2 is very small, 10 raised to power minus 10. In this case, the equilibrium mixture will be mainly intermediate product because this is very high. Right? So in different cases, we have different what you call steps which are fast and slow depending on the k1, k2 values. So use of overall equilibrium constant for calculation equilibrium composition is limited to cases where the intermediate products are not present in significant amount. यहाँ significant था तो यहाँ पर ignore नहीं कर सकते हम. In this case, we cannot ignore it, right? So it is significant. We cannot ignore it in this case because it is significant again. Right? Only in this case where the intermediate is small quantity or limited quantity, then we can ignore it. समझ में आ रहा है आप लोगों को? केसेस डिफरेंट केसेस लेके क्या देखा हमने कि फर्स्ट रिएक्शन k1 if k1 is very small compared to k2 we can ignore it. We can ignore the intermediate formation. But if k1 is comparable or more than k2 then we cannot ignore it. We have to consider it. ठीक है? ठीक है. So let us look at all possible reactions. क्या क्या हो सकते हैं. So there are different reactions which can happen when CO and hydrogen react. One is formaldehyde formation. Second one is methanol formation. Third one is CH4 formation. Then again C2H6, C3H7O5. Different reactions can happen, but concentrations or product quantity may be limited. But these are all possible reactions. So in this reaction, which is used for synthesis of methanol, side reactions are assumed to be negligible compared with main reaction, because क्या होता है कि main reaction ये है हमारा, this is the main reaction, and others are all side reactions. तो जनरली ये होता है कि ये बनता है बट क्वांटिटीज आर वेरी स्मॉल, मेन रिएक्शन की क्वांटिटी ज़्यादा रहता है. Okay. So theoretically, when equilibrium yield of product is to be determined, we should consider all possible reactions, right? Consider करना चाहिए, but practically it is not possible because quantities may be very small, 1%, 0.1%, whatever, it's very, very small quantities. So general case, what we'll do is we'll derive all these things for all compounds and then we'll see how to use it. So we're considering all the cases, but उसको simplify करते हैं. Then you simplify it. You consider C, जैसे हमने देखा था, right? We derived what you call VLE for complex case as well as simple case. अगर ज़्यादा इफेक्ट नहीं है तो then we make assumptions, जैसे हमने assume किया था ideal gas and ideal solutions to simplify the problem, because you can solve it for complex case, but if it is not going to make any significant difference in the answer, then we make suitable assumptions to simplify the problem. Okay, so let us look at what is general case. If we consider all the reactions, then what do we get? Okay, so equilibrium equations of all reactions must be satisfied by composition of the system. If we consider all the cases, therefore determination of equilibrium composition involves simultaneous solution of R equilibrium reactions or equations. Right, जितना reactions रहेगा उतना हमारे को equations मिलेगा. Right, so equilibrium constant for each reaction we can write K is equal to pi of AI raised to the power of nu I. This is for one reaction. अगर J reaction रहेगा 3, 4, जैसे हमने देखा 5, 6 reaction देखा ऊपर, right? So we can write for jth reaction is equal to pi of AI. AI is essentially activity of component I raised to power of nu I, that means stoichiometric coefficient for jth reaction, right? So ये जो है ये jth reaction है, right? बाकी सेम है, यहाँ पर एक reaction था, one reaction था, तो it was basically one reaction AI raised to power of nu I, but when you consider more than one reaction, then we have to have separately K for each reaction. So K of reaction 1 will be pi of AI raised to the power of nu I for first reaction. Then Kj, let me write it down for you. So it will be like K1 is equal to pi of AI raised to the power of nu I for first reaction. Then K2 will be pi of AI raised to the power of nu I for second reaction, like that, depending on कितने reaction है. ठीक है? So we know that K is equal to K5 into Ky p raised to the power of nu, general equation derive किया था हमने, and K5 is equal to 1 for ideal case, ideal gases. So K is equal to Ky p raised to the power of nu for one reaction. ये हमने किया, right? We have done many problems for gas phase reaction. Gas phase ही ले रहे हैं अभी, because we assume ideal gas here. So K for jth reaction will be p raised to the power of nu j, that means nu for jth reaction, into p ky is nothing but pi of pi I raised to the power of nu I raised to nu I comma j for jth reaction, right? So jth reaction के लिए ये रहेगा और ये रहेगा, or we can write this as ky for jth reaction is equal to kj, which is this one, and p raised to the power of minus nu j. Any questions on equation 5? Then यही है जब पहले वाला equation है, we're just centralizing it for more than one reaction. More than one reaction रहेगा तो more than one k value रहेगा, जो देखा था हमने, right? k1 k2 वगैरह, and we are saying कि कैसे होगा for each reaction, right? So write R equations for R reactions. ये जैसे ये equation 5 है, right? k1 ky for first reaction, ky for second reaction, ky for third reaction, fourth reaction, like that for R reactions. Okay, so if you take a reaction like A times A plus B1 times B equal delta L plus M1 times M, right? Reaction 1 here, ये K1 रहेगा equilibrium constant, epsilon 1 extent of reaction. And if you write second reaction, suppose this is an intermediate, right? We are talking about this as intermediate, right? कहाँ गया? ठीक है? So L is an intermediate. So L is formed in the first reaction, equation 6 here, and then it's consumed in the second reaction, which is 7, right? L times L plus B2 times B gives M2 times M plus N times N. So this is the intermediate we are talking about. So for this reaction 2, K2 is the equilibrium constant and epsilon 2 is the extent of reaction. And we assume that initial mixture is 1 mole of A plus X moles of B. So there's some ratio, right? It could be 1, it could be 2, it could be anything, doesn't matter. General equation है. So what you get is yi is general equation था हमारा. We have seen this, right? Ni upon total moles is equal to Ni0 plus summation over J nu ij epsilon j upon n0 plus summation over j nu j epsilon j. Derive किया था हमने equation, right? For multiple reactions at the beginning of our unit 5. ठीक है? Any questions or doubts so far? So what you'll get is n is equal to this n total number of moles is n0 plus summation of nu j epsilon j over j reactions. So n0 is what? 1 plus x plus अभी ये करने का हमारे पास, right? We are doing this for nu j epsilon j over jth reaction. So अगर first reaction लिया, suppose we take first reaction here, this reaction, right? A times A plus B1 times B is equal to L times L plus M1 times M. तो उसके लिए क्या हो जाएगा? L times epsilon 1 is first reaction plus M1 times stoichiometric coefficient of M1 into epsilon 1 minus A times epsilon 1 minus B1 times epsilon 1, right? This is the stoichiometric coefficient A, B1, L and M1. Okay? And then for the second reaction, it is L, B2, M2 and N. Right? For second reaction, you can write for summation over all reactions. Second reaction के लिए M2 into epsilon 2 plus N into epsilon 2 minus L into epsilon 2 minus B2 into epsilon 2. So this is for the first reaction. This is for reaction 2. So if you can combine these things, you get N is equal to 1 plus X plus epsilon 1 बाहर निकाला यहाँ से, L plus M1 minus A minus B1 plus epsilon 2 यहाँ से बाहर निकाला, get plus epsilon 2 into M2 plus N minus L minus B2. right? And we can write y, that mole fraction of component A is 1, initial moles 1 tha, minus A into epsilon 1 upon n, because A is only in reaction 1, right? A was only in reaction 1, right? So 1 minus epsilon 1, A into epsilon 1 upon capital N, YB, which is second reactant, दोनों reaction में है, right? B is in reaction 1 and reaction 2 both, तो दोनों term आएगा दोनों reaction का, x moles था initial moles minus B1 into epsilon 1 minus B2 into epsilon 2, stoichiometric coefficient B1 और B2 था, divided by n. Y of L is intermediate, right? So intermediate is formed in the first reaction, यहाँ पर form हो रहा है और यहाँ पर consume हो रहा है, right? So दोनों आएगा L into epsilon 1 formation in the first reaction and consumption in the second reaction minus epsilon 2 upon n. M is formed in both reactions, right? यहाँ भी form हो रहा है और यहाँ भी form हो रहा है, right? Getting formed here as well as here. So you get y of m is equal to m1 into epsilon 1 plus m2 into epsilon 2 upon n, and yn is formed in the second reaction यहाँ पर. So what you'll get is only one term, yn is equal to n into epsilon 2 upon n, right? So these are all the mole fractions for all the components, and we have seen that ky of jth reaction is equal to kj into p raised over minus nu j. So substitute all these equations in equation 5, and what we'll get is ky for first reaction is equal to yl to the power of l, stoichiometric coefficient, ym to the power of m1 against stoichiometric coefficient, ya to the power of a, and yb to the power of b1 is equal to, again, k1 into p raised to the power of minus nu j. Nu j is nothing but first reaction के लिए minus of l plus m1 minus a minus b1, right? And similarly for second reaction, ky for second reaction is ym to the power of m2 stoichiometric coefficient, yn to the power of n divided by yl to the power of l, and yb to the power of b2 is equal to k2 into p raised to minus stoichiometric coefficient m2 plus n minus l minus b2. Right, so you get these two equations for k for the two reactions. So to solve equations 15 and 16 to get epsilon 1 and epsilon 2. So now we have two values of epsilon for the two reactions, epsilon and epsilon 2 के लिए solve करना पड़ेगा, and then we can calculate equilibrium composition. Right, ये equation हमने derive किया था, right? Once you get epsilon values, you can calculate what is the equilibrium composition of each component. Any questions or doubts? Simple derivation है, ज़्यादा नहीं है, थोड़ा complex लगता है because you're talking about more than one reaction, but similar है what we done before. It is just find k values for both the reactions. ये सेम था, हमने पहले एक रिएक्शन के लिए किया था, अभी दो रिएक्शन के लिए करने का है. And we have to solve separately, solve these equations to find epsilon 1 and epsilon 2. Any questions? Silence is golden, is it? Yeah, if there are no questions, then we can stop here.